Section 2.6 is more applications. We're going to start, as does the textbook, with Part A, consecutive integer problems. On page 194, there's a chart that talks a little bit about what consecutive integers are. Consecutive just means one right after the other or right next to each other. So two consecutive integers are 3 and 4, or 19 and 20, or even -7 and -6. They're right next to each other, one right after the other. Remember that integers are whole numbers, either positive or negative, or 0. So two consecutive integers are any two numbers right next to each other. 3 and 4 are right next to each other. 4 is one more than 3. 19 and 20 are right next to each other. 20 is one more than 19. -7 and -6. -6 is one more than -7. So if they're consecutive, two numbers will have the values x and x plus 1. The first of the two consecutive integers is whatever that number is, but the second one is one more than that. That's what this means here. Two consecutive integers are x and one more than x plus 1. The kinds of problems we're going to be doing in this part of this section are things like this. The sum of two consecutive integers is 15. Well, here's my is, which means equals. And the right-hand side then of this is the 15, is 15. But what is 15? The sum of two consecutive integers. The sum of an integer and one more than that integer. The sum of two consecutive integers is 15. So what about three consecutive integers? Well, three integers are consecutive if they're one right after the other. So 3 and 4 are two consecutive integers. 3, 4, and 5 are three consecutive integers. Here's an example that uses three consecutive integers. The sum of three consecutive integers. Well, if the first integer is x, the next consecutive integer is x plus 1, as we talked about up here. The next one after that is this integer plus one more. I could write x plus 1 plus 1, and then combining like terms, I get x plus 2. So three consecutive integers are 3, 4, and 5. 3 plus 1 is 4, and x, 3, plus 2 more is 5. Four consecutive integers would be x plus 1, x plus 2, and x plus 3, adding 1 to each of the previous integers. So the sum of three consecutive integers is x plus 1, and x plus 2, the three consecutive integers, added together, the sum. And that sum is 24. Two even integers right next to the other, or one right after the other, would be something like 6 and 8. They're the two integers right next to each other which are even. Another example is 102 and 104. These are consecutive even integers. 103 is actually what comes after 102. 102 and 103 are consecutive integers. But if I'm talking about even integers, and I'm interested in consecutive even integers, then the two even integers that come right next to each other are 102 and 104. Notice what I have to do to get from 6 to 8. Now I have to add 2 to get from one integer to the next consecutive even integer. I have to add 2 to 102 to get to 104. So if I know my first integer, to get to the second consecutive even integer, I have to add 2 to the first one. 2 consecutive even integers are x, or whatever that first integer is, and 2 more than x. In a consecutive integer problem, I'll be asked for things like the sum of what? The sum of 2 consecutive even integers. Here's the first one, here's the second, 2 more than the first one. And that sum is 18. The sum of 2 consecutive even integers is 18. I've saved this one for last because it seems to be the one that throws most people. I'm now talking about 2 consecutive odd integers. If an odd integer is 7, the next consecutive odd integer would be 9. 8's even, so I have to leave that out. So 7 and 9 are consecutive odd integers. 13 and 15 are consecutive odd integers. Negative 21 and negative 19 are consecutive odd integers. What do I have to do to the first one to get up to the next one? I have to add 2. To get from 13 to 15, I have to go up 2. And negative 19 is 2 more than negative 21. Whatever my first odd integer is, the next odd integer is 2 more than the first one. What throws people is that if 2 consecutive even integers are a number and 2 more than a number, when they see the word odd, they think the first integer has to have some odd number added to it. But the thing is, whether they're even or odd, to get from one even integer to the next, we have to go up 2. To get from one odd integer to the next, we also have to go up 2. So whether you're dealing with consecutive even or odd numbers, whatever the first one is, you need to add 2 to get to the next consecutive even or odd number. Here's our example problem for this part. The sum of 2 consecutive odd integers is 28. Find the 2 integers. Well, I'm working with a sum, so I know I'm going to be adding 2 things together. And I know that when I do that, the sum is 28, or equals 28. What I have to do now is figure out what 2 things I'm adding together. The sum of what? The sum of 2 consecutive odd integers. The sum of one odd integer and the next consecutive odd integer. Well, any odd integer is 2 more than the odd integer before it. If x was 3, the next odd integer, 5, is 2 more than x, 2 more than 3. So this is the sum of 2 consecutive odd integers, and that sum is 28. I used parentheses when I first wrote this problem out, just so that you could see that I was adding this integer to this integer. I'm not just adding 2 to x. I'm adding x plus 2 to x. The sum is the sum of this odd integer and this next odd integer. Now that I've done that, I don't really need the parentheses. And I can use combine like terms, the addition property of equality, and the multiplication property of equality to solve my equation. The problem is, this hasn't answered the question. The question is, find the 2 integers. I've only found x, my first integer. What's my second one? Well, since x is an odd integer, the next one, x plus 2, is 13 plus 2, or 15. Of course, the other way you can approach this is just to say that since x is 13, the next one, the next odd integer, is 2 more than that, 15. My two integers are 13 and 15.